Right. Greetings, Earthlings. I'm about to take you on a journey to an alien world, which predominantly is pitch black and temperatures can exceed boiling point. 95% of this world remains untouched. And no, I'm not talking about some distant exoplanet. It's actually much closer than you would think. It's right behind us, our ocean. Despite how little we actually know about this alien world, we are well aware of its effects on the climate and the environment, and ultimately ourselves. Unfortunately, we are contributing to its demise, and I need your help to reverse these changes, and I need you to understand why it's important to study the oceans. I hate to say it, but it may be even more important than space exploration. So first off, why do we put so much effort into shooting people strapped onto giant missiles into an endless void? I believe it starts with this quote: "We do these things not because they are easy, but because they are hard." President John F. Kennedy. Thanks to those words, we now know much more about space, especially our solar system, than we could ever have imagined. We now know that there is water on 4 other celestial bodies in our solar system, all of which very well could have life. These 4 water worlds include Mars, which has an ice cap on one of its poles, Europa, an icy moon of Jupiter with potentially breathable air, and a liquid ocean hiding under its smooth icy surface. Enceladus, which is essentially a much smaller version of Europa, but is a moon of Saturn instead, and ejects water hundreds of feet into space from its icy geysers. And last but not least, the reject of our solar system, Pluto, which recently was discovered to have entire mountains made out of ice, and likely also has a liquid ocean beneath its surface. However, according to SciShow Space, the celestial body that scientists are really beginning to zero in on for the search for life is Enceladus. NASA's Cassini spacecraft went through several plumes from geysers on Enceladus. They discovered that it was composed of water with a similar salinity as our oceans: carbon dioxide, hydrogen, ammonia, and methane. All of these components are essential for chemosynthetic life, which doesn't need sunlight. While these are very incredible and significant discoveries, it is very expensive to make these discoveries. For example, according to Dr. Robert Ballard, in the documentary miniseries Alien Deep, NASA, the National Aeronautics and Space Administration, has more than 100 times the funding of NOAA, the National Oceanic and Atmospheric Administration. And right now, NASA is trying to get to Mars. A couple billion years ago, Mars likely had an atmosphere very similar to our own, one that was dense enough to support large bodies of liquid water, oceans. However, according to NASA, Mars lost its atmosphere from solar wind and radiation. A small amount of carbon dioxide still remains in the atmosphere, and the rest is stored as carbonate or dry ice. The current consensus is that there is not enough carbon to restore the atmosphere. Elon Musk believes otherwise, though. All in all, it would be very expensive and unsustainable. So, cutting back on space exploration in order to find a more sustainable solution makes sense and all, but what about finding the origin of life? Well, you don't have to go to Enceladus to figure that out. The answer is miles under our seas near tectonic plate boundaries. The answer could likely be found around oceanic hydrothermal vents that pump out superheated, high-nutrient water near a magma chamber of undersea volcanoes. This sounds like such a hostile environment, yet life flourishes here, with a very high biodiversity. Although the communities typically only last a couple decades before they are devastated by a volcanic eruption, but they still manage to bounce back in very little time at similar densities. Right. So, how are we compromising the health of our ocean? There are a few major impacts, but the most prominent by far is our carbon footprint. Temperature increases with an increase in greenhouse gases such as carbon dioxide as a result of IR radiation, which is absorbed and scattered by greenhouse gases. Thus, the more greenhouse gas, the more scattering, and the longer the IR radiation will stay in the atmosphere, contributing to warming. An increase in temperature will also contribute to an increase in water vapor, which will scatter more IR radiation. Prior to the Industrial Revolution, carbon dioxide levels were at 280 parts per million. and now it's at over 400 parts per million. According to NOAA, in the last 800,000 years, carbon dioxide levels have ranged from 180 parts per million during ice ages and 280 parts per million during periods of warming, as indicated by ice core samples. In other words, we were already in a period of warming, and increased carbon dioxide is only accelerating that warming. This warming will render a higher sea level due to the melting of our ice caps. We wouldn't want to cause a water world like the 1995 movie where people are recycled and terrorized by smokers. However, the most frightening aspect of carbon emissions is not sea level rise, but it's the implications for the next major mass extinction. The culprit is ocean acidification, which is caused by a decrease in pH due to an increase in carbonic acid, which is a product of carbon dioxide and water. The impacts are already apparent through mass mortality of corals worldwide. According to the Netflix documentary Mission Blue, from 1950 to 2014, there was a 50% decline in corals worldwide. The lower pH forces corals to eject zooxanthellae, which is a dinoflagellate phytoplankton that forms a symbiotic relationship with corals. Zooxanthellae produces a toxin at a lower pH that corals can't stand. The process is called coral bleaching. The more acidic waters also break down the calcium carbonate that makes up the structures of corals and a multitude of other marine organisms. This will destroy carbon stores in the ocean and ultimately lead to a total collapse of the ecosystem, taking away Earth's primary source of oxygen. The oceans are responsible for 70% of atmospheric oxygen. This has happened before, but instead of humans causing it, volcanoes were the culprit during the PT Permian-Triassic mass extinction 251 million years ago. This extinction was considered the worst mass extinction in Earth's history, with about 90% of all species going extinct in a few thousand years, according to Dr. Deanna Connors. In conclusion, there is no future for our species if we don't start caring about and making more efforts to explore our oceans. So try to make lifestyle changes to reduce your carbon footprint. Also, luckily for you, you're in the perfect place to make a direct impact. Get out of the house and volunteer for organizations that help to promote conservation, such as Restore Our Shores. Restore Our Shores strives to restore seagrass, mangrove forests, and oyster reefs in the Indian River Lagoon. The restoration of these habitats helps to sequester carbon dioxide, combating against ocean acidification, and they also uptake nutrient pollution, which prevents a more localized problem known as eutrophication, or nutrient enrichment from fertilizer runoff, which leads to massive algae blooms that are decomposed by oxygen-dependent bacteria that depletes oxygen and suffocates sea life. So please, get involved.
Thank you.